What is it that we are interested in here? The true proportion of kids that want to be a doctor, yes. Check if the conditions for constructing a confidence interval for P are met. How many conditions are there? 3 conditions. What are those 3 conditions? 10%. Random. Law of large counts. Yes, we need to check for normality. So is randomness met? How do we know? Random sample of 1,000 kids, so randomness is met. Is 10% met? Yes, how do we know? There's more than 10,000 kids under 12 in the nation. We need to make sure that we're looking at our whole population here, so we want to try to be very specific there. And the last thing was law of large counts. How do we check for that? N times P, so 1,000 times what? 0.055. And we come out with 55. 55 is bigger than 10. And then we have to go and check the other one. So 1,000 times 0.945, 945, bigger than 10. We are good. Find the critical value for a 98% confidence interval, then calculate the interval. So our confidence interval, our critical value is going to be 2.33. So we want our tail proportion. So I do 1 minus 0.98 divided by 2 because we've got 2 tails. We want to capture that middle 98%. So I do inverse norm of 0.01. Technically, I got negative 2.33, but that just tells me that it's 2.33 standard deviations to the left. I would also go 2.33 standard deviations to the right. So whatever my confidence interval is, 1 minus that percent divided by 2, and I do inverse normal of that. And that will give me my critical value. How do I calculate my confidence interval from there? Multiply the critical value by not just my p hat, by my margin of error, or that'll find my standard error. We're going to find the margin of error by taking the critical value times the standard error. How do I find the standard error? Yes, square root of p hat times 1 minus p hat over n. We're going to multiply that by our critical value, 2.33. This is going to give me my margin of error. And then we will do our point estimate plus or minus the margin of error. So when we do that, let me just pull it up here. I got the margin of error to be 0.017, so our point estimate of 0.055 plus or minus 0.017. So I got the interval of 0.038 to 0.072. And then interpreting that in context, since we went with a 98% confidence interval, we are 98% confident that the interval from 0.038 to 0.072 captures the true proportion of kids who want to be a doctor. What does it mean to be 98% confident again? Does that mean there's a 98% chance that the true proportion is in there? No, the true proportion is decided already. We don't happen to know what it is, but it is decided already. What were you going to say?
98% of the samples will come out between 0.038 and 0.072.
So when we say we are 98% confident, I want you to remember as we constructed a lot of these confidence intervals, I heard a lot of really good things. There's just a couple things that I want to tweak in that conversation there. If we were to repeat sampling over and over and over and over and over, we do this many, many, many samples, and we were to calculate a confidence interval for each one of those samples, for each of those point estimates, if we were to calculate a 98% confidence interval for each sample that we took, about 98% of those confidence intervals would capture the true proportion. This is not a probability that we're talking about here. I just want to make sure that we're really clear. We're not talking about chances. We're not talking about probabilities. We're saying that if we were to repeat this over and over and over and over and over again, about 98% of our intervals would capture whatever that true proportion is. And we're using this to try to estimate the true proportion. Does that make sense? I think one of the best analogies I ever heard for why we're not talking chances here, why we talk about being confident. If I hold a coin in my hand and I ask you, what's the probability that when I flip this coin, it lands on heads? 50% chance or 50% probability. If I flip the coin, catch it in my hand and cover it up and I say, is this coin on heads or tails? It's now no longer a chance, it's happened already. It's been flipped. So now you would be 50% confident in your guess that you guessed correctly. Does that make sense? Okay. We are going to keep talking, estimating population proportions here. If you need to grab a quick screenshot of what's up on the screen, go ahead and do so before I take it down. Right. Go ahead and pull this down so I can put the next page up. Taking me just a minute to get up on the screen. Okay. We want to try to estimate what proportion of the Earth is covered by water. We're going to investigate this question by taking a random sample of locations on the globe. So I need somebody that's willing to keep a tally for me. I want one or two people so that we can keep a tally going. I've got a Google Earth random generator here that's going to pick random locations on the globe. I had a plan to bring in, my daughter has this globe stuffy, but I couldn't find it last night. So we were going to do it that way, but I couldn't find it. Sorry. Right, we are going to sample 50 different locations on the globe. Got random geographic coordinates. All we care about is whether or not those coordinates are landing in water or land. So we're looking for the proportion that are water. So we're going to count landing in water as a success, and we're going to ignore anything that lands on land. So picking my random coordinates. Landed on water, so we want to count that as one success. That is one trial so far. Here we go again. That is water again, 2 trials. 3. 4, right on the coast, but technically land. 5. 6, 7. I feel like I can't hardly see that. What do you guys think, land or water?
There's a zoom out.
Oh, there is. Did I miss that? Yes, thank you. Let's zoom out. We have landed in water. That was number 7. 8. On the coast. Let's zoom in and see if we can tell for sure. Yep, on the coast. 8. 9. That is water. 10. I can't tell. Water. That was random sample number 11. We are 12, 13, 14, 15, 16. I'm up to 10 lands in the water so far, 16 trials. 17, 18, 19, that is water. 20, 21, 22, 23, 24, 25. Let's go in. This is 25. It landed in a lake, but it is 25. I'm at 15 so far. Are you guys at 15? Okay. It's 25, 26, 27, that is water. 28, 29, 30, 31, 32, that was on land. There it is. Yeah, 32 was on land. 33, 34, landed on land. 35, 36, 37, we're in water again. 38, 39, 39 is on land. 40, what are we at so far? 23? Okay, so we got 10 more to go. 41 is on water. 42 is on water. 43 is on land. 44 is in the water. 45 is on land. 46 is on land. 47 is on land. 48 is in the water. 49 is in the water. And I can't tell. Let's zoom in. Oh my goodness. What do you guys think? I think we count that as water. I had to zoom in really far. Of course, that would be the very last one. What was our proportion? 29 out of 50. All right, let's go ahead and write that down. 29 out of 50. Sorry. How many locations were water? 29. Calculate the proportion of locations from your sample that are water. What is our p-hat value? 0.58. Construct a 95% confidence interval to estimate the proportion of Earth that is water. This is a 4-step process. This is the first time we're being introduced to this 4-step process. This is a process that you guys are going to need to become more and more and more familiar with. We state, we plan, we do, and then we conclude. So the first thing we're going to do is state the parameter you want to estimate and the confidence level. What is it that we are wanting to estimate? Yes, the true proportion of Earth covered by water. And up here in part 3, it said construct a 95% confidence interval. So our confidence level is 95%. So parameter P the true proportion of Earth covered by water. So far, so good? And our p hat is 0.58. We are going to use a one sample Z interval test for P. That is the name of the test that we are going to be using. We took one sample of 50. We're using a Z interval, and we are using this to estimate the true proportion P. What are the conditions that we need to check here? Normal, 10%, and that's my normality. Random. Do we have a random sample? How can we show that? Or what could we say to show that? Random sample of 50 locations on the globe, and we used our random location generator to do that. All right, so let me get this written down. Random. We did a random sample of 50 locations. Why do we do that? Generalize, yes. So we can generalize to the population. In this case, the population would be every location on Earth. 10% condition. How do I check that? 50 locations, less than or equal to 1/10 all locations on Earth. Multiply both sides by 10 is 500 less than or equal to all locations on Earth. Yes. Why do we care about that? So we can find our standard deviation. So sampling without replacement is okay. We can't find our standard deviation if sampling without replacement is not okay. So sampling without replacement is okay. Which allows me to use my formula for standard deviation. Last thing we need to check is what? Large counts. So large counts, I'm going to do over here because I ran out of room. We're going to do n times p hat. So 50 times, what was our p hat? 0.58. What is 50 times 0.58? You said how much? Not 0.29. I don't know why I wrote that. So 29 greater than or equal to 10. And then we do n times 1 minus p hat. So 50 times 0.42. 50 times 0.42 is how much? 21 greater than or equal to 10. Why did we need to check our large counts condition? Yes. So we know the sampling distribution is approximately normal. State what we're looking for and the confidence level. We are trying to estimate P, the true proportion of the Earth covered by water. We're doing this at a 95% confidence level. Then our plan, we identify our procedure. One sample Z interval test for P, or Z interval for P. We checked our conditions. Now we are ready to do. So now we are going to construct our confidence interval here. The general formula for any confidence interval. What is my general formula? I'm looking for words here, not formulas. Yes. Point estimate plus or minus the margin of error. That is always how we're going to construct a confidence interval. Point estimate plus or minus the margin of error. Now, the specific formula for this test that we are doing with our numbers substituted in here, we're going to get to that. So the point estimate, since we're doing a proportion, point estimate is going to be P hat plus or minus. I need two pieces in order to calculate the margin of error. What is one piece that I need? Z star, our critical value, we need Z star. And then I need what? I need my standard error, which we calculate just like a standard deviation, but we call it a standard error because we're doing it from P hat, not with P. So that would be the square root of what? P hat times 1 minus P hat over N. What was our point estimate? 0.58 plus or minus, what is Z star for a 95% confidence interval? What is our critical value? What is Z star for a 95% confidence interval? 1.96. We're going to multiply that by the square root of 0.58 times 0.42 all over what? All over 50. So 0.58 plus or minus, and then we're going to find our margin of error. What did you guys get for just the margin of error part? Yes. I'm sorry, I thought I saw a hand up. So that 1.96 times our standard error. I know it starts with a 0. 0 point what? I got something a little bit smaller than that. Yeah, I don't want the standard error, I want the margin of error. So 1.96 times that radical there.
137.
Yep, 137 or 1368, depending on how many digits you write out. So now I want to construct my interval. So I'm going to do 0.58 minus 0.137. Oh, was this, were you giving me part of the interval? There we go. Okay, you were just a step ahead of me there. 0.58 plus my margin of error, 0.717. Okay, so here we have constructed our confidence interval. And now we have to conclude. How would you conclude this? We are 95% confident that the interval yes, that the interval from 0.443 to 0.717 captures the true proportion of Earth covered by water. Does anybody happen to know how much of the Earth is actually covered by water? So technically, it falls almost precisely at 71%. About 71%, which is just a little bit more than 2/3, about 71% of Earth is covered by water. So what is the true value for P then? 0.71. Did our interval capture the true proportion? Yes, barely. It was on the upper end. But our interval did capture the true proportion of Earth covered by water. So this is called the 4-step process for constructing a confidence interval. State, plan, do, conclude. That is one of our big ideas for today. Oh, sorry. There we go. 4-step process. State, plan, do, and conclude. You guys are going to need to remember what this 4-step process is and what is involved in each step. State, we're going to say what the parameter is that we are trying to estimate and the confidence level that we're going to do that at. In the plan stage, we're going to name the procedure that we're using. In this case, we've only learned one procedure so far. We have a 1 sample Z interval for P. We will learn more in the next chapter. Do, we want to do our general and specific formulas. So point estimate plus or minus the margin of error is always how we construct a confidence interval, and then we want to look for the specific values or the specific formulas for our test. Then we're going to plug in our numbers and calculate that interval. Then we will conclude by interpreting the interval in context. One thing that we did not go over in our investigation of water on Earth is choosing a sample size. A lot of times when you're going into a study, you're planning a research study to take a sample, you need to know how big of a sample to choose. So if we have a given margin of error and we have a given confidence interval, we're going to substitute in and we're going to solve for n. If we don't know p hat, we're going to use a very conservative calculation. We're going to assume that our proportion is 0.5. That is going to give us the largest sample size we would need in order to calculate a specific margin of error with a specific confidence level. once you are done copying this down into your notes, I want you to try number 1 on the check your understanding. I want to get through that one today if we can, and then we'll save parts 2 and 3, or B and C, sorry. Parts B and C. They keep changing it on me. 2 and 3 we'll save for Monday. Look quickly at number 1 on the check your understanding. So my margin of error is equal to Z star times times the square root of P hat times 1 minus P hat over N. We're going to solve this for N. What is our margin of error? Yes, 2%. So we're going to put that in here, 0.02. What are we putting in for Z star? 1.96. We want 95% confidence interval. And then the square root, we're going to use a conservative estimate for P hat. What is our conservative estimate for P hat? 0.5. So I've got 0.5 times 0.5 over N. One of the things I want to caution you guys about, one of the things that I have been told repeatedly to caution you about is when we're doing this calculation, we are not going to round until the very end. So if you're going to put things into your calculator ahead of time, make sure that you're keeping the entire value on there. So the first thing I would do is divide both sides by 1.96, but I'm not going to put that in my calculator yet. I'm just going to write it down. So I have 0.02 divided by 1.96 equals the square root of 0.25 over N. I did go ahead and multiply that numerator together. How do I get rid of the square root? Square both sides. Again, I'm just going to leave it written with the squared there. So I have 0.02 divided by 1.96 quantity squared is equal to 0.25 over N. How do I isolate N? Multiply N on both sides, and then I'm going to divide by this squared fraction on both sides. So now I get to where I would type things into my calculator. N is equal to 0.25 divided by 0.02 divided by 1.96 squared. That is what I would type into my calculator to get our value for N. This one, surprisingly, comes out to a whole number. What'd you get? 2,401. If we round in the process, it is going to change substantially our final value for N there. Monday, first thing when you get in, I'm going to have you guys try number 2, kind of following this same type of path. And then we'll look at number 3. We will finish the very last thing that we need to cover in chapter 8. which is looking at a difference of proportions. 8.2 homework is due on Monday. On Monday, when we start the very last section, I will give you your 8.3 homework. It's very short. It's just the front side of a worksheet because we only have one day on that.